Right, ladies and gentlemen, we're moving on. So today we're dealing with trig functions, but namely inverse trig functions. So what's going on is you'll be given a triangle, and you'll have some side lengths, but you won't know the angle measure. And since trig functions are the same value regardless of how big or small the triangle is, if you can set up your ratio, you can get the angle that's there, the angle that's missing. For instance, let's say I want to find this amount here. Like, what's the degrees of this angle here? Well, I have this angle, and I have a hypotenuse length, and I have an adjacent length, meaning the side next to it. That's not the hypotenuse. Well, the trig function that goes with that is cosine. Remember, cosine of any old angle is adjacent over hypotenuse. And so, if I fill this equation in with the information that I know, I got cosine of question mark is going to equal 12 over 17. Well, this is my ratio. It comes out to be some decimal number. If you can figure out what the angle is that goes in here, it'll make the equation true. So that's the goal of this. And the way to do that is by using this thing called an inverse trig function. So much like how when you square things, the way to undo that is using the inverse, which is square rooting. Right? You got squared, and then you got square root. The opposite of multiplying something would be to divide by that, and that's the inverse. Well, with sine and cosine, there are inverse functions that take your ratio and tell you the angle. And the way it works is you're going to open up your calculator. If you have a graphing calculator, or you have a scientific calculator, or you use this online calculator, they should all do it assuming they're at least a scientific level kind of calculator. So I'm going to open up the Desmos one, which there should be a link in the Canvas module, or you can just look up Desmos scientific calculator. It'll show up. And what you're going to do is it's going to look like this. You definitely want the scientific one. And then down here, before we start pushing buttons on other things, we're going to go to this little slider here. And we want to make sure it says deg, and that's short for degree. The other option is rad, which is short for radians. We are going to learn about radians, but those are later. Right now, you want it in degrees because we're trying to figure out the angle in degrees. So make sure it says deg for degrees. And then you're going to come to the left of it just a little bit and look for FUNC, func, which is short for functions. And here on the left side, you'll see there's sine, there's cosine, and tangent. You don't want all of those. Just clear all. You want the inverse of our trig function. So sine, cosine, tangent, we don't want those ones. We want the inverse, which is the negative, the negative 1 power. And so since our problem we were looking at is cosine, we want to do inverse cosine, which is cos to the negative 1 power. And it's going to open up a set of parentheses, and you want to type in your ratio, which the one we have is 12/17. And so I'm going to type in, you have to go back over to main to get to your numbers, or you can type it on your keyboard. 12 divided by 17. Oh no, it broke it. I got to go back. Go back. We want to get in that parenthesis there. Cosine of 12 divided by 17. And then you can close your, parenthesis there. And here on the right side, you'll get a number. That is the inverse cosine of 12 over 17, which means that is our angle. That is 45.099 degrees, and it keeps going. I would like for you to round to the second decimal place. So here, I'm going to write out what we did. We did inverse cosine of 12/17. And we got 45.099. What else do we have? Open up. 1, 2, 7, 8, 4. I'm just putting these here so you can kind of 7, 8, 4. I think that's what I said. And we're going to round this off. So that's going to be about 45 if we round to the second decimal place, we look at the next number, it's 5 or bigger, so it's going to round up, which makes this turn into 10 instead of just 9. So I'm going to put 10. And so that is actually our angle measurement there is about 45.10 degrees. And that's the whole process. You set up your equation, fill in the numbers that you have, and then use the inverse trig of it to get that missing angle. So this is pretty quick. Let's see, what's a good one to... Yeah, let's jump over this one. So 16 here. I would like for you to pause the video and see if you can set up the equation. Which trig function is it? And then put the numbers in the right spot. All right. So if you're using tangent, good job. That's because we have the side opposite it and we have the side adjacent to our angle. We do not have the hypotenuse. So this is going to be tan, which is opposite over adjacent. And our opposite side is 16. The adjacent side is 27. And now we have our trig function set up. To get this question mark, you have to do inverse tangent, so tangent to the negative first, of our ratio on the right side, which is 16 over 27. And push enter and you'll get a number. So I'm going to jump over to my scientific calculator. You should pause the video, see if you can get it all by yourself. All right, I'm going to go to function, inverse tangent, and then, sorry, I forgot what the numbers were, 16 over 27. So 16 divided by 27. I'm going to close that parenthesis there. And on the right side, I got 30.650667, And so I'm going to go here. I just forgot the number. 30.65, and it keeps going. And since this wasn't the exact number, I'm going to put the squiggles, which means approximately. So I'm going to put that. And so my question mark is approximately 30.65 degrees. And that's pretty much it. You just set up your equation and then do the inverse trig function of whatever it has. I do want to show you that if you don't put it in the right kind of degrees and radians, you're going to get a drastically different answer. Actually, if I switch it right now, you'll see the number on the right. My answer switches. And that's because radians and degrees are not the same type of units. It's almost like converting between feet and inches. Not exactly that, but it's that idea. It's right. Different kinds of units. There's radians and degrees. We want degrees. But there you go. That's how you do the whole thing. Should be pretty easy today.